As John said, I'm Sarah, and I work at Facebook Research here in New York. And I have a lot of experience taking AI research and making it work in practice. So I'm going to talk about that tonight. And I'm really casual, so I have a lot of content here to kind of talk about my experiences, but it's great if you want to ask questions throughout, and I'll just warn you that maybe some of the more interesting insights are at the end. Okay, so one thing I wanted to talk about that I think not everybody knows is really what are these AI research labs, right? So I work in FAIR here in New York, which is Facebook AI Research, but before that I was with Microsoft Research. And at Facebook, we also have another lab called AML, or Applied Machine Learning. And a lot of people think of these, when we think of research, we think of kind of, projects that are being done specifically for the company. And actually, all of these research labs we're talking about are what we sort of call academic-style basic research labs, where the idea is, the only goal is we're trying to advance the state-of-the-art of AI. We do everything in the open, we publish. We're not specifically trying to do things for Facebook's products or Microsoft's products. So the goal is basically, we want to try to solve AI and for the world and not specifically for our company. Now, one of the benefits of this is we do end up producing things that tend to be useful in our companies along the way. But so a lot of the work I'm talking about is stuff that you could use in your company. It's open source, it's published, it's technology that's available and out there. And so I started as a researcher in in Microsoft Research, and I found that I wanted to go not just from sort of creating the new technology, but actually making it work in practice and making it work in practice for a lot of customers, for a variety of scenarios, and really just trying to make AI real. And so I spent the last year on the leadership team for a lot of the data products in Azure, working both with Azure to get AI into more products and also working with a ton of Microsoft's enterprise customers to help them build AI solutions for their applications in Cloud Platform. So a lot of what I'm going to talk about today comes from that experience. And now my new role at Facebook is to lead projects that are part research and part products so that we can get AI into practice faster and have a bigger impact with our AI innovations. Okay, so can't give an AI talk without answering the question, what is AI, right? We're hearing a lot about it these days. Sort of traditionally, and the way people have thought about it is that AI is kind of including everything you need to reach human-level intelligence and human-level capabilities. And that is kind of the classical definition of AI, where we're just trying to make humans from computers. However, these days, there's kind of an emerging definition in the field that's more about intelligent automation, and can we use AI to understand the world and make decisions for us or automate the world? And so this would also include things like superhuman capabilities, which is a term we use for things that actually humans aren't very good at, but computers can be really good at. So for example, analyzing a lot of data and finding a pattern in it, humans aren't very good at that. AI is pretty good at that, right? And so a lot of the work is really in these kind of capabilities. And then a new area where things really are going are these human-in-the-loop systems or AI solutions that are about taking what the machines are really good at and what humans are really good at and putting them together in a way that is better, right? So you could think of this as, for example, having in medicine, having an algorithm that makes recommendations and finds anomalies, but you still have a doctor who's making the ultimate decision, right? And so there's a lot of cases where we're really looking at solutions like that. And these days we would consider kind of all of these patterns AI and not just the classical definition of AI. So when people are talking about AI, it's kind of just this intelligent automation with or without people. So so now, especially over the last couple of years, that expanded to include a lot of research areas. So algorithms and machine learning is where a lot of this started recently, but it really also includes infrastructure and systems and the technologies to implement this, and also robotics. I put a picture of this Boston Dynamics robot here because it doesn't do any learning, in fact, but most of people now would kind of consider this in the realm of AI research. And so I think there's a lot of jargon around AI. There's a lot of, it's a pretty large area these days, and so I thought it was sort of helpful when we're thinking about using AI in practice to kind of point out that there's largely sort of 3 buckets of types of learning algorithms. And the reason I'm going to talk about this is just that I think if you have an understanding of the different underlying technologies, it's easier to understand what applications they'll actually work for. So I'm going to talk a little bit about traditional machine learning and a little bit about deep learning, but a lot of my experience over the last year is in a newer kind of AI called adaptive learning, so I'm going to mostly talk about the technologies for that. Okay, so what now we're sort of calling like traditional machine learning or classic machine learning is really pretty simple to understand. This is kind of, if you've ever taken any math or machine learning course, this is exactly what you would expect. It's, let's take a data, for example, I've got some red dots and some blue dots here, and let's learn a simple function that allows us to, in this case, separate the data or understand the data, right? And so it's usually learning fairly simple functions. This works really well to sort of predict future values, for example, or predict what category, like a new dot, if it's over here, it's pretty easy to predict it's probably a red dot. So you can think like spam, not spam, or what is my sales going to be next week, right? And so this is actually used a lot in practice in the big companies. It turns out that even though we have fancier, heavier weight technology, this is good enough for a lot of problems. And so it's definitely not something to be overlooked, especially there's a lot of hype around a lot more computationally expensive AI, but in practice, this actually works in many cases. So deep learning, on the other hand, this is where all the hype is, and we're hearing a lot of buzzwords around this. It's also called, the underlying models are called neural networks or deep neural nets or DNNs. But the idea with deep learning is that we're actually going to learn a graph of functions to represent something. So it's a much more intense model. It's much more computationally intensive. This is the reason NVIDIA's stock is really high now. And historically, deep learning has been, and deep learning is kind of the reason we're having the big AI hype now, is that it works really well on perception tasks, and we finally started hitting breakthroughs where we're above human level of perception for things like image recognition. So you can think of this as doing, what's in this image, or speech recognition, or anything around natural language processing and all of that. So if we're talking about deep learning at Facebook. So our Facebook AI Research Labs actually started here in New York City, and we have one of the fathers of deep learning as our lab director, and so we're all about deep learning at Facebook. It's basically throughout the products, and we have a huge amount of research in this area, but I wanted to highlight a couple technologies we have that are, I think, kind of interesting and also available, open source, available for you to use in your products or your work. So one of them is text understanding. So we have something called fast text that makes it easy to understand what a sentence is talking about, what it's in there, and this is used just throughout our products now, and that's available externally. I think one of the most exciting things we've recently published is around translations. So in Facebook, when you go, and now you can, if a post is in another language, you can translate that. That's technology based out of the lab here in New York, and that's a deep learning technology. And it's open source, it's available for you to use. We have a new sort of novel way of doing that that's getting really great results. One demo we like to give, which is a picture here, is real-time style transfer. So this one is, my boss really likes to live stream videos of himself with like some sort of Picasso filter or Van Gogh filter. So if you would like to, look like this in video, you can with this technology. So we're doing both like fun things with this and also serious. It's also the foundation for a lot of our business functions that you can imagine, like ads and news feed and important things like that. Another really cool thing that we're doing that is a problem that a lot of people have is I have users, they have a complex series of actions or profiles that they've done in my environment, and I want to make decisions. I want to recommend a news article to them or an advertisement, or I want to recommend who they should be friends with. And so we have something called World to Vec, which is about taking a whole complex sort of state of the world of a user and turning it into a simple representation that can be used by other AI to make decisions. And so that's another thing we're doing so that we can kind of represent users' whole experience on the platform and make intelligent decisions based on all of their experience. And so that's kind of a sample of different deep learning things that we're doing at Facebook. But these days, this is really sort of the foundation of a lot of this perception stuff. And so then I'm going to talk about a project quickly that I'm leading, because I think this is exciting for anyone that is using deep learning tools. So at Facebook, about a month ago with Microsoft, we announced something called Onyx. And Onyx is about creating a standard way to represent deep learning models so that it will work with every single tool. There's a problem in the ecosystem right now that your developer needs to pick a tool chain. You need to decide whether you're going to run PyTorch or you're going to run TensorFlow or you're going to run any of the other tools. And once you're in there, you're locked in. And we found that we had a big problem where the frameworks and the tools that you want to use when you're developing stuff, when you're experimenting, when you're iterating, are not the ones you want to use when you go to production. So what we wanted to do was make it possible to transfer models from that development environment into the production environment, but also basically to make it so that people can mix and match the tools however they want in the ecosystem. So if you're new and one of your products really needs this and another one needs that, we want it all to be able to work together. Also so that Microsoft, Amazon, Facebook, everybody can kind of contribute to the tools ecosystem together. So this is a collaboration with about 7 other companies now, and it's an open source project that people can get involved with. But the idea is hopefully to make the tools ecosystem better for everyone in deep learning. Okay, so to kind of get to the more interesting part here, there's a new type of machine learning that we're just starting to use in practice. It's new for being used in practice, and it's evolving rapidly. And this is what we call adaptive learning. People also call it reinforcement learning, if you're used to the technical names. But the idea with reinforcement learning is, if we look at the learning process for any application, for any data-driven thing, there's basically 4 steps. The first thing is you need to explore, you need to collect data, right? So if I'm trying to decide, we were just talking about A/B testing, if I'm trying to decide which campaign I want to run, I'm going to run some exploration. I'm going to try one campaign, I'm going to try another campaign, right? And I'm going to collect all of the data, and I'm going to log that data. And then I'm going to learn from that data. I'm going to bring in my data scientists, bring in my machine learning people, and I'm going to actually learn a model. Then I have to go and deploy that new model back. And you just go around and around in this loop because the world is constantly changing, and so you have to keep doing this over and over again. And the thing about this is, actually, at big tech companies, for high-value problems, we have a separate team for basically every part of this process, right? Every part is difficult, every part is important, and it's a significant effort to go around this entire loop. So if you're talking about things like search engines or other things where the foundation includes a lot of machine learning, we'll have large teams for each of these things. And the problem is that makes it really hard in practice. The loop can go wrong because you can have issues with the data is getting corrupt in the system, it's not getting passed between teams correctly, people don't understand what the other team is doing. And then also just in runtime, applications will do things. For example, let's say you're trying to run a new campaign and you want to see if this will work. You might have a downstream system say, oh, this campaign doesn't seem like what we normally run, let's not put it up because, or if you're, for example, doing social media optimization, oh, we decided to run this, but then Facebook's algorithm never showed it, right? And so you have this problem that the runtime systems are often built of mini algorithms, and so things can go wrong there too. And so the general issue is just that running this loop is really complex, and there's really subtle errors when this meets large systems in the real world and real infrastructure. And so one of the things that's exciting about adaptive learning is that adaptive learning algorithms handle this entire loop in the algorithm at once, and so it makes it harder for us to have these errors. It also makes it possible to do this loop very rapidly. So, for example, in some of the large companies, to go around this entire loop, to go from experimenting to new data to deploying a new model, might take weeks or a month. And this is for important things, where with an algorithm, the version I'm about to talk about, we're going around that loop every 5 minutes. So every 5 minutes, we're looking at the state of the world and deploying a new model. So there's a lot that's kind of exciting about adaptive learning. And let me give you a concrete scenario to kind of explain, how to make this real. So the idea is, let's say we have, one user who is really interested in browsing sports, particularly at a particular time of the week, right before he makes his fantasy picks, right? Then you might have a totally different user who actually is going to the news site because she wants to prep for a meeting that she has with a client in a particular location, right? And so one of the problems with our products right now is that in a lot of cases they're going to see the same content or very similar content, or maybe they'll see different content as each other, but it's not going to be adaptive based on where they are and what their needs are at that moment. So the idea with a lot of this adaptive learning is the state of the world is changing, and you want to do different things for different people or different things for different situations, and so let's create algorithms that can learn what to do in what case and also adapt as the state of the world changes. And so I'm going to talk mostly at the moment about kind of content for this because it's really easy to understand, but you could also imagine that you could use this in your infrastructure to say, okay, let's change the thresholds as the system changes, like where the security thresholds could evolve over time, or when you decide to put something to sleep evolves over time. So this doesn't have to be specifically about content, but it's algorithms that can sense the world and automatically adapt. So if we look at reinforcement learning in general, this is exactly how it looks. The idea is we're going to observe some state of the world. So if we're talking about news, that might be the user profile. Maybe we know their demographics. Maybe we know what they've read in the past, right? And we also then have some choices we need to make, right? So we could pick either this food story or a story about space and say, which action am I going to take? Am I going to show them this one story or this other story? Or am I going to show them this ad? And then the last thing we want to do is we want to observe some sort of outcome, right? The reason we're picking an action is we want something to happen, right? We want the user to click on the story. We want them to convert and purchase the thing, right? We want them to sign up for the website. And so the idea is we have some sort of action. And so the goal of the algorithm is we're just going to constantly try to intelligently select actions that get the outcome that you want, right? And we're going to do this over and over again so that we learn from the past and we learn as we go. And that's the idea of reinforcement learning, is to just keep doing this over and over again and trying to get the best outcomes. And so the other thing about reinforcement learning, since I don't have a slide on this, is it's based on experimenting. This is the same way that we learn, we were just talking about A/B testing. It's the same idea, but it's built in. So I can't tell if you like a political story unless I occasionally show you a political story, or I show users like you a political story and I see that they read it. So the algorithm, in order, when it's choosing an action, it's trying to choose the best one, but sometimes it chooses actions to get new information. And so the algorithm actually experiments, it does that exploration step and loop, and then it learns new things. And so in practice, the thing about reinforcement learning is people are really excited about it. It has a lot of promise, and I'll kind of show you why in a second, but there's actually a lot of limitations still. For example, each action has to be independent, so I can say show this user this article, show this user this article, things like that, but I can't say show this article and then this article and then this article to a user. And then I think more importantly, it needs to be a small set of actions, so you can't yet dump your entire catalog of the million different ads that Facebook can show and just say pick, right? It needs to be like pick among 100 things. So in practice, we often use another type of algorithm to rank the top 100, and then we'll use this reinforcement learning to learn what to do on the top 100. And to give you some intuition for that, it's because of the exploration. We can't explore over 1 million options. It's just too expensive, right? And so the idea is you just want to explore over the ones you think are probably good, right? And you don't want to try something that's never actually going to be good. So when I was at Microsoft, we turned this research into a cloud service. So it's a little bit of a product advertisement for Microsoft because you can use this, but it's also open source, so you can use it that way. But the idea is we took all of these algorithms and we made it easy to plug into your application. So if this is your app, a user can show up. You say, here's all my features. Here's that state of the world. Here's that user profile, everything I know. And you ask this decision engine, tell me which article I should show, or rank the list of articles I should show. What should I do? And then it sends that to the cloud, and well, it tells you here in line, and then you also say, how well did you do? Yes, they converted, they clicked, they spent 10 minutes reading, whatever reward you care about. And the idea is then this is going to learn in the cloud and send a new model as it improves. And so, as I mentioned, the version that we have deploys a new model every 5 minutes, so you can adapt really rapidly. And it's a simple API that makes it possible for people to use this. And I think the reason this is actually really novel is this is all the research papers we've published on the algorithms in the system, just in our group in New York here. Right, like this stuff. Yeah, so basically, these algorithms are pretty complex, but what's really cool about putting them in the right infrastructure, putting them in the right system, is that we actually have some customers who don't even have a data scientist, where one developer was able to put this in and personalize their homepage using basically the state-of-the-art, brand new, published a month ago algorithms. And so this is why I put infrastructure at the beginning, because this is a really important part of this story, is in order to make this stuff work, you need the right infrastructure. And if we're really going to make AI everywhere, we're going to have to make the tools and the infrastructure to make it available, not just hiring lots and lots of data scientists. So we built this service, and the first thing we did is put it into MSN to power MSN's homepage. And MSN's actually pretty huge. They're in 52 countries. There's hundreds of millions of customers, and so it's a pretty gigantic property, actually. And our goal, they were using other machine learning, and so our goal was to increase user engagement by about 3% for this. 3 to 4% would be like a really big success for this team. And so the first thing we did was we ranked this part of the page. So the algorithm just says, show this article, this article, this article, and they tile the out. And MSN decides how to tile it. We just say, this is the best one, this is the second best one, etc. And what happens is we actually ended up with, in 2 weeks, about 30% increase in clicks. So yeah, this was everyone was pretty excited. We won an innovation, the MSN team won an innovation award. This is generating a lot of revenue. So this is a really big success. And sort of to give you an intuition what's happening here, the algorithm is because it's adapting every 5 minutes, it can adapt to breaking news, and it's constantly trying different things, and it's finding things that people would really be interested in. And so it's basically both about being able to adapt very rapidly and also being more personalized. So about half the gains come from being smarter and faster, and the other half are from being kind of more personal. And so we've actually done this just a bunch of places now, and the numbers are similar whether we're in MSN or we did a similar thing with Yahoo News. We've done some startups now with ads, and the reason I'm pointing this out is this is why I think this kind of technology is so promising. Is it's just like this startup case, they don't even have a data scientist. It's one developer plugging it in, and we're getting 30 to 40% lift in like high value problems. And so I think there's a lot going there. And so I'm kind of talking about content recommendation because I think it's easy to understand that, but there's actually tons of places that you can use this same thing. So another thing that we're doing now is ranking sales leads or selecting which campaign is the right pitch for that particular sales lead. We are working in system infrastructure to say, okay, given this whole situation and the state of all my performance counters, should I reboot my VM? So you can use things like that. We're also using it. One of the cool projects that Microsoft Research is doing this for personalized medicine, giving the state of your genome and your medical history and your particular cancer, what's the right cancer treatment for you, right? And so basically we're trying to take this very adaptive, powerful learning technology and put it in a variety of settings. So I think it's very promising. But I think also what's interesting is kind of the lessons learned from this. So I put the system architecture up. This is a cloud system, and the reason I'm putting this up here is to show you, as I mentioned, we have a simple API, send the feature vector, get the decision back, send back the outcome. But each one of these is a different cloud service in Azure. So to encapsulate these algorithms, we have to build several different cloud services. And what's cool about the cloud is that we were able to do this with 2 developers, but still, right, we're still managing a system of several different cloud services. And that's just, to support these learning algorithms. In addition, we found that we actually, and the reason we built the system is that we had tried deploying it in several other places, and it failed every single time because it would go wrong somewhere in these subtle errors. And so we weren't even it wasn't even possible to get these algorithms into systems of practice without building a separate system that was guaranteed to be correct by construction, that was guaranteed not to have errors. And so the other thing that we had to build in is a lot of things to make sure that this adaptive learning actually worked. We have to make sure that all of the learning is reproducible because statistical bugs are very, very hard to debug. And so it looks like, oh, the learning's not working. Why? And then, oh, actually, some value is getting corrupted somewhere in the system, right? But it's very hard to debug. We also have to build in online monitoring. We have to build in statistically correct compression and also data deduction, all sorts of reduction. So there's a lot of things we had to do to build in a system that actually works for machine learning that's correct by construction. And even with that, it's still hard to use in a lot of cases. A lot of the magic, if anyone has been doing this kind of stuff, is you still have to fit your problem into the machine learning. So as I mentioned, for example, 100 actions is kind of the magic number. So you have to build some machine learning system that gets you to that to then use this other one, right? Or we need an outcome to optimize, and so you need to be able to say, I really care about clicks, or I care about conversions, and I need to be able to measure those, right? And so and maybe what I really care about is long-term revenue, but I can only measure clicks, right? So you have to figure out how to make the machine learning match what you're actually trying to accomplish, and that can be a big challenge in practice. It's much easier in the settings I was just talking about, but it's still not a walk in the park there. But if we're talking about more important settings, like let's say I want to use this to be a wellness coach, to every day set your step goal, depending on maybe you're at a conference and you're going to walk less, but then maybe the next day that you should walk more to make up for it. Well, in those cases, it's hard to know, did that actually get the outcome that you want? How do I measure that my step coach is doing a good job, right? And so there's a lot of issues in how we actually measure the outcome. There's still a lot of tuning required, and we still need experts in many cases to tune things, and there's just a lot of other sort of common traps. My whole team ends up giving talks like this, what are the common pitfalls of trying to do this stuff in practice, because there are still a lot of them. And so that's kind of one of the challenges. I think that we have had a bunch of successful deployments now because we built a system, and we built a system that's correct by construction, and we moved a lot, but there's still lots of other challenges, right? And so it's definitely an ongoing thing to figure out how to sort of make this real and make this scalable so that AI is something that many people can use and not just experts in it. I think the one other issue I just wanted to bring up, this is a whole separate talk, but I just don't want to give an AI talk without mentioning it. We have big issues with AI ethics, right? And there's a lot of research and a lot of work to figure out how to be done. And then just to highlight kind of the topics in this space, we're working, at Facebook we're working on these things, some of the other labs are working on these things, but there's a lot of work to be done, so we need more work in this space. But how do we make algorithms fair? How do we make sure that if this algorithm's adapting, that it stays fair, it doesn't learn, if it's learning directly from real data, how do I make sure that it doesn't learn things that are in the data but aren't the way we want the algorithm to behave? Or how do we make sure that it's safe, and how do we make sure it's safe as it evolves? And then how do we know that these things are true? How do we audit them? How do we understand what the algorithm is doing? And then an issue around, well, all of this is very data-driven, so what does privacy mean in this setting? If we're giving very, very personalized recommendations, at some point is that violating privacy? And so there's huge issues in this space, and we're taking it very seriously, and this is something that everyone needs to figure out together. But this is another thing that's a reality when you're thinking about this now, is what can sort of go wrong when you're putting these algorithms in your problems, because they can have sort of real effects. So here's sort of my closing thoughts. Here's Mark Zuckerberg announcing our AI lab. I think there's big potential for AI in business applications and all sorts of applications. The numbers I mentioned have significant revenue lift behind them, and we also many other high-value applications where we're sort of seeing significant improvements because of AI. But it's just not turnkey yet, right? It's, we're working as quickly as we can to democratize AI and make this usable, but it's not an area that you can really put in your applications without some amount of investment, some amount of understanding of what this means. And I think, one of the big takeaways through all this experience for me is it's really worth doing the infrastructure investments up front. It's really worth making systems that you know are going to be correct or are going to be less likely to have bugs. I think this is essential. So if you're looking at AI for your applications, for your company, understand that a lot of the upfront investment in making sure that you have the right tools and the right experimentation system and all of that is going to make a big difference. And an example here is the leader of our applied machine learning lab has talked about this in, I think, like Harvard Business Review and stuff recently. But Facebook started getting some of the biggest wins in ads because they built infrastructure to test which ads are better, A/B testing, test which model was working better. And so that the biggest improvements came not from better algorithms, not from hiring smarter ML people, but from building infrastructure that made it easy for us to tell if our algorithms were working, right? And so I think that's the other thing, is just to understand that this is actually, significant sort of systems and infrastructure investments at this point. And just, I have a ton of links to all the tech I mentioned and lots more details if people want to know. Questions?
Yeah, so when you mentioned that you're measuring clicks, and so if I go to MSN.com and I always click on sports news, then the algorithm will think, he's coming to our website, let's only show him sports news, or gradually, as time goes on, keep clicking on sports. But what about making a person a little bit more well-rounded, showing him tech news and stuff like that?
Yeah, so I think this is a topic that's really important at Facebook, and was something that we thought about at MSN and Microsoft too. And I think that's another thing that's challenging about the AI in practice is these algorithms will go after whatever metric you want. So if it's clicks and you only click sports, after a while your homepage would just look like sports, right? And so part of the challenge is making a reward function that values things besides just clicks, right? So I might value more that they're clicking on a different type of article than they normally click, right? I might value more if maybe I want my algorithm, people find the headline news, I want my algorithm to surface the things they wouldn't normally find, so I'm gonna, value like diverse clicks, right? So those are things that you have to construct the reward function so that the algorithm does it. And I think there's lots of open questions to how to do this for things like Newsfeed or MSN, right? I think what content people are consuming is clearly something that everybody cares about a lot and is thinking a lot about. But for the algorithms, it's just you could write a super complex reward function that says, I want to make, somehow you've mathematically written down, I want to make the American public more educated, right? Then if you've mathematically written that down, the algorithm's going to go after it. But a lot of the challenge is figuring out what do you want the algorithm to go after. For example, clicks, right? Nobody really wants a property that's just filled with clickbait. So you usually have to make a function that's not just clicks. Yes?
Hi, Claire. So I think your presentation is phenomenal as far as being simple and clear. So absolutely a fantastic use of my 2 hours. I have a question about the adaptive learning slide.
Mm-hmm.
So one of the challenges in the artificial intelligence space is that we personify, use verbs to personify, right?
Mm-hmm.
So on that particular slide, you're saying that we observe the adaptive learning will observe the world,
Mm-hmm.
right? Which obviously you can't really do that from a system standpoint.
Yep.
My clients will ask questions like, does that mean you're doing keystroke logging, or what do you mean by the verb observe, which applies to a human? So I'm wondering if you could articulate what observe the world means in your world.
Yeah, so the answer in this, the real technical answer is we have an API that says send me a feature vector, right? So we observe a feature vector that you send. Now, in let's say for MSN, for example, the feature vector that they send includes user profile, like a history of what they've read, maybe other information they've put in their MSN profile, and it also includes like, here's all the topics of the articles, and here's what's trending on Twitter, and here's all of this other information, right? And so mathematically, we mean send us a feature vector, but the application could choose to send any different information, right? And so in the case of the systems setting I was talking about, where we say, let's decide if we should reboot a VM, if it's unhealthy or not. In that case, it's send all the performance counter numbers, right?
Right, so like essentially aggregated data gathering, and then that gets pulled.
Yeah. So the application needs to decide what information is relevant and send it. So there's still a lot of magic in making sure that you're sending the right information. Yeah. And featureizing it appropriately, which is one of the challenges for everybody.
Mm-hmm.
Yeah.
This gentleman says, have you figured out a way to express mathematically or give a rule for important but not necessarily popular? For example, I've been in the news business and I've dealt with, Pulitzer Prize-winning reporters who published articles that were extremely important but not necessarily popular, and they may have affected change a decade later, nuclear power or whatever. So, my question is there a way to teach a machine important but not necessarily measurable in popularity the ways you were expressing?
Right. So I think, this is more of a question around, again, so to explain to people how it works, this reward function is just a number you send back. So you could write a rule system that says, okay, I've decided this article is extremely important, so I'm going to give 100 points anytime someone clicks on it. This other article, I'm going to give 1 point anytime someone clicks on it. Yeah, exactly. So our algorithm doesn't care what that function looks like. I haven't seen any work on how to make, in the news space, let's say, how to make a function that is, let's say, representative of different things you'd care about, like the quality of the articles, and also maybe the brand, the tone you want to set for your site, and the pieces you think are important and all of that. But that's at this moment kind of out of the realm of the algorithms and in the realm of the product and the product experience. Mm-hmm.
Is all of this actually currently deployed in the newsfeed? Or still in the research?
So the adaptive learning stuff is this Microsoft Decision Service. It's a product you can go use. So that's deployed in quite a few places inside of Microsoft, and also with quite a few Microsoft customers. All of the Facebook things I talked about, the different deep learning things, are used in our products. That applied research lab does exactly what we kind of did for the decision service at Microsoft. They take these basic text, they figure out how to build them into systems to make it possible for Facebook engineers to actually use them in products. We had an article about our learning system that makes it easier for people to use machine learning, and now I think the number we've published is, a quarter of engineers in the company use this system, like every single week, right? So, yes, all of this is in our products. It's in platforms that make it easy to put it in our products, but it's also, available for people to use in not platform form.
So, sorry,
Mm-hmm.
clarifying question. When I say deployed, I meant like in the newsfeed?
In the newsfeed?
At Facebook, is it deployed there where the content you see is actually, or I guess these algorithms are defining what content you see?
Okay, so there's not, okay, so all of the textual understanding, the translation, the word to vector, like profile stuff, all of that is in the news feed. I can't talk more about the larger control of the news feed, but yes.
Does World Effect help with the featurization problem?
Yeah, it's making embeddings that you can use as features in your neural nets.
Have you run into an application where you need to look backwards and say, January 11th, this is what I showed this user, this is what they did, kind of an evidentiary or recallable? That ethics slide somewhere.
Wait, so are you asking for ethics reasons or for being able to learn from historical data?
I'm asking for the integrity of the data. I know for a fact that I asked Lenny.
Yeah, so.
If I showed Lenny these two things, this is the one that
Yeah, so I just flew through the fact that reproducibility was huge. One of the biggest things that was going wrong when we were trying to do this was logging, and so we built logging into the system. So it's separate from your main logging infrastructure. We have separate machine learning logging to do exactly that. So we have a log that looks like, here's the articles I can pick, here's the user, here's what I showed them, here's the outcome. And there's actually a cool thing about this, which is pretty technical, but that means you can actually go and do counterfactual evaluation. You've tried all these different things. Now you say, what if in the future I showed Lenny this? And you can have a much higher quality estimate of how well you're going to do if you do that. So there's also reasons you want to do that.
Time for one last question.
There's one over here that.
I work in the customer service space and helping between next best action and stuff like that.
Mm-hmm.
That's all reactive. Holy Grail is proactive.
Mm-hmm.
We see what might be in that terms of, we know situations like this that we know the customer might have a problem.
So there's definitely people working on proactive. I think the space that you see this happening the most is in assistance, because if you want to build a deeper relationship with something, it's better if it's also reaching out to you, if it's teaching you about its features. So there's definitely people working on that. Those kind of problems are more about the product problem of how do I know I did a good job, and what are the choices of things I can do proactively, and how to then, like these algorithms will work for that if you can figure out how do I explain the state of the world, and how do I know I did a good job, and all of that. So a lot more of that is in the product innovation. Okay.
Thanks, Sarah.
I'll be around, so if you have more questions.